We are now learning about torque acting upon an electric dipole. Although torque is a topic of class 11th, but here there are no prerequisites. So you will be able to understand torque in class 12th itself just by little effort, just by listening to me carefully. Now visualize an electric dipole which is a system of minus q and plus q is kept at an angle theta with this uniform electric field lines. This is the dipole and this is the line of dipole moment, and the angle between the dipole moment vector and electric field is taken as angle theta. Now the two ends plus q and minus q will now be acted upon by an attractive and a repelling force. As we know it that this field is going to be due to some charge distribution, and we are assuming that that charge distribution is positive. So minus q charge will be pulled by some force, say Fa at point A, towards the external charge that is producing the field, and plus q charge will be repelled by this field. So there will be two forces, equal, opposite and non-collinear. They are acting along different lines. These forces are equal, they are acting in the opposite direction, and they are non-collinear. They are not on the same line. So when such two forces act, visualize a rod kept and you just pull the two ends by some forces here, it is going to rotate. So torque is nothing but rotatory effect of such forces which are equal or unequal but opposite and non-collinear. So here we have equal, opposite and non-collinear forces generating a rotatory effect, and that rotatory effect is called torque. And that rotation can be easily accounted by marking this angle theta and marking this perpendicular distance in front of theta. So there will be two such perpendicular distances, perpendicular 1 and perpendicular 2, because dipole ultimately is going to align itself parallel with the field. Ultimately it's going to be parallel with the field. So when you visualize this, the net perpendicular distance, perpendicular 1 plus perpendicular 2, is for this half length as L sine theta and for this half length as perpendicular 2 or L sine theta. When these two L sine thetas combine, it becomes 2L sine theta, and torque now becomes either of the force. It is not the net force. Net force in this case is going to be 0. It is either of the two forces multiplied with the perpendicular distance travelled from line of action of force. That is the formula of torque. Either of the two forces and net perpendicular distance. If you take this as force, the net perpendicular distance is perpendicular 1 plus perpendicular 2. This as the force, the net perpendicular distance is perpendicular 2 plus perpendicular 1. So either of the forces into 2L sine theta, that makes it QE into 2L sine theta. Q into 2L is taken as P. So the result is PE sine theta, and torque can be written as P cross E. Direction of this torque is such that it will align the dipole parallel with the field. It will align the dipole parallel with the field. We can very easily describe that the direction is going to be P cross E. Thumb inside, it means some kind of a rotation is occurring here. It is trying to align the dipole parallel with the field. I hope this point is clear.